If you look at today's post, your assignment is to just do numbers 16 through 27. And of course, it's just recommended practice, right, for today. But I also want you to try out a couple of the first part of the worksheet. But let's just jump right in and look at number 16. You see, yesterday we reviewed different methods of factoring. It's kind of like if you have a factoring toolbox, you got to analyze the situation and determine which tool you want to use that's appropriate, right? So right here we have a standard form quadratic trinomial where your A value is 1, your B value is -4, your C value is -12. And we said when we do have one of these and the A value is 1, you could use this format to factor with an X right here and an X right there. I mean, you could try to use it, right? The reason why we could try to set it up like this is because X times X is X squared. If you had a 5 right here, you wouldn't be able to set this up. If you had a 3, you wouldn't be able to set this up. The only reason you're able to set this up is because the A value is 1. There's no number in the front. Anyway, the process that we learned yesterday was you got to think what times what is the C value that if you combine together is the B value. So I always recommend make a list. I always make a list and I start with the number 1 or -1. So in this case, to get -12, I want to write -1 times 12, and then -2 times what? 6, and then -3 times 4, okay? So we have those 3 possibilities, and which pair of numbers combines together to give you the middle value -4? This gives you 11, that's not 11. This gives you 4, that is a 4, but we want it to be a -4, not a +4, right? If I combine -2 plus 6, that's +4. So we have the right numbers, we just have the wrong signs. So all you got to do is change both of those signs. And those are the 2 numbers that go inside here, +2, -6, and that is factored, right? So the question is, why the heck do we go from this quadratic trinomial, why do we want to end up with 2 binomials that are being multiplied together? The answer to that is because of zero product property. Yesterday we also covered that if you do have something times something else and the answer is 0, then that first something could have been 0 or the second something could have been 0. So the beauty of zero product property is that it takes something that looks complicated, split it into 2 simple, most of the time 1-step equations, sometimes 2. So the answer to this one is x equals -2. The answer to this one is x equals +6. And both of those are your answers for this question number 16. Now, the reason why I didn't print this out was because I tried to do it myself when I printed it out, and I had to write super, super tiny. And I figured, you know what, it's better for you guys just to copy down each question. That way you could have all the space that you need. On my work, on the solutions that I posted, I didn't show all my work. Like right here, I didn't show the -2, or the +6. So I hope you guys, I had to squeeze it in on the solutions, so hopefully you don't get confused when I don't show certain steps. Any questions right there? So again, that's just one tool that we have in our toolbox on factoring. When your A value is 1, you could think what times what is C that if you combine together is B. But there are many other tools that we learned in factoring in our factoring toolbox. One of them was pulling out the GCF. That's the first tool you're supposed to attempt always. Another one was when you had a perfect square in the front and a perfect square in the back, you might be able to square root them and then plug them into your answer format. Or you might have use a combination of the 2 where you factor out the GCF and then continue factoring on the inside. So let's just jump around and do a couple of these. Let's take a look at, let's say number 21. People get confused with 21. First of all, when we're solving equations, the whole purpose of factoring is to get multiplication so you could have something times something equal to 0, so you could apply zero product property. Right here, you don't even have equals 0. So let's begin with setting that up. Set it equal to 0. Subtract 4x. Subtract 4x. Now, you can't really subtract x squares from x's. They're not like terms. So you're just going to rewrite it. 7x squared minus 4x equals 0. So now we have the equals 0. Now let's worry about factoring. What could I factor right there? Do I have the A value of 1 where I could think what times what is the C value? No, it doesn't work, right? Is this a perfect square number that I could square root? No, I can't. Okay. What other tools do we have? What's the first tool we should use? The GCF. Could you pull out something in common from this binomial? There's two terms here. Could you pull out something in common? Is there a multiple in common with 7 and 4? No. If it were like 8 and 4, yeah, you could pull out a multiple of 4. But 7 and 4 doesn't work. But at least we do have x's in both terms, right? So I'm going to pull out one x. That's my GCF. The x is my GCF. Now what would be left on the inside? 7x minus 4, right? Yes? Okay. So why would I want this instead of this original one? Well, because the original one, I can't apply zero product property. But now that I have something times something equals 0, now I could apply zero product property. If this times this equals 0, then that first something could equal 0, and the second something could also equal 0. That's why on the notes yesterday I told you guys to highlight or underline those three words: factor, split, and solve. Again, we're factoring, we factored it to this, and now we're splitting it, and now we're going to solve both equations. Now if you think about it, that first one is already solved for you. X equals 0 is x equals 0. That's actually an answer. The other one, you're going to have to go plus 4, plus 4. You're going to have a 7x equals 4. Final step would be to divide by 7, divide by 7. So your answer there would be x equals 4/7. So your two answers for number 21 are x equals 0 and x equals 4/7. Make sense? Okay. Let's jump around here. How about 25? That one looks fun. What could I do? What kind of factoring could I apply on the left side? GCF? What is the GCF? What could I pull out of the left side of this equation? A 5. Okay. What would be left over on the inside? X squared. What else? The middle term?
7.
Minus 7 with an x. Last term? Plus 12. Okay, good. Now this is equal to 0. Okay. We pulled out the GCF. Look at the inside in blue. The inside in blue now is a standard form quadratic trinomial, and the a value really is 1. So now that we have that, we could jump to that other factoring method where we put an x right here and an x right there. And we simply think, what times what is my c value? 12. That if I combine together is my b value, -7, right? So again, I always say make a list whenever you're thinking of what times what is c, that if you combine together is b. So how could I get 12? It's going to be a 1 times 12, or a 2 times 6, or a 3 times 4, and that's it. Because the next number would be 4, you'd be back to 4 times 3, which is 3 times 4. Anyways, which pair of numbers combines together to give you the middle value, -7?
3 and 4, but the sign.
There you go, 3 and 4, but the signs need to be changed. Because 3 plus 4 is 7, that's great, that's the number we want, but we want it to be negative. So we have the right numbers, we just have the wrong signs. So all we do is change both of those signs and plug them in. -3, -4. Don't forget about the original GCF 5 that we pulled out, okay?
Can 4 be positive too?
The 4 cannot be positive because -3 times +4 would give you the -12, not +12. It's all about the multiples of +12. So they're either going to all be positive or all be negative in this case. All right, anyway, so we have 5 times x minus 3 times x minus 4 equals 0. And right there, we could also apply the zero product property with these 3 items, right? This first thing, you could set it equal to 0, but it's not going to make sense because 5 does not equal 0. So you could just forget about the 5. But the x minus 3, that could equal 0, and you could solve that. And the x minus 4, that could equal 0 as well. Again, up here we have 5 times this equals 0. You have something times something times something equals 0. You could split them all up and set them each equal to 0. Right here, it doesn't make sense, so just scratch it out, forget about it. And right here, both of these will give you your 2 answers. X equals 3 and x equals 4. Again, I didn't show my work. Let me do that real quick. Bless you. There's my work. Okay. Another way of doing this problem, check this out. Copy this over. Move this over here to the side. Another way of doing this problem would be to, you could do anything you want to an equation as long as you do it to both sides, to the whole thing. So if you wanted to, instead of pulling out the GCF, you could technically divide by 5, divide by 5, divide by 5, and divide the 0 by 5. Then that way you'd have x squared minus 7x plus 12 equals 0. And you would still end up with the same factoring situation, same answers. Does that make sense? Yeah. But since we are practicing that first tool, factoring out the GCF, that's why I decided to show my work and factor out the GCF. Anyway. What else? Let's just do one more here. 18. Let's factor that. Anybody know? What times what? Actually, let's work through it step by step. My list. 1 times 8. 2 times 4. And that's it. Which pair of numbers combines together to give us the middle value? -6. Yeah, 2 times 4, but change the signs. Because so -2, -4. So now we have something times something equals 0. So that first something could equal 0, and the second something could equal 0. So we obviously have our two answers, plus 2, x equals 2, and plus 4, x equals 4. Okay, now I want to pause right here because the first part of this worksheet, even though it's not assigned for homework right now, I'd like you to actually, once you finish this, try a couple of the first part of the worksheet, because the first part of the worksheet, they give you 2 roots. They say, we're giving you 2 roots, which are answers, which are x-intercepts, which are solutions, whatever you want to call them. They give you the answer 2, they give you the answer 4. And they want you to come up with the quadratic equation that produces these 2 answers. They want you to come up with this that produces these 2 answers. Okay? So it's just a question of working backwards. It's like saying, if you have this answer, where did the answer come from? From what binomial did it come from? It came from the binomial. Imagine subtracting 2 and subtracting 2. It would take you back up here to x minus 2 equals 0. Over here, subtracting 4, that would take you back to the x minus 4 equals 0. Does that kind of make sense? Working backwards? I guess it's probably better to actually look at a question like number 1. So even though this wasn't part of your homework, the instructions say write a quadratic equation in standard form with the given roots. First thing we need to do is remember the notes that roots mean the same things as answers, same thing as x-intercepts, solutions, real zeros. They all mean the same thing. The 7 and the 2 are answers. So what we need to do, I would go way down here to the bottom and put x equals 7 and x equals 2. Those are your answers that they give you up here, 7 and 2. Where did this answer come from? It came from a binomial that was set equal to 0. What is that binomial that's set equal to 0? Where did it come from? X minus 7, right? I mean, even if you were to move the 7 over here, you'd end up with the x minus 7 equals 0. And how about the other answer, x equals 2? Where did it come from? X minus 2 equals 0, right? So it's kind of like having your answers and working backwards till you get to the quadratic equation. So right here we have this binomial that was set equal to 0, this binomial that was set equal to 0. That came from a split. All right, so what I want to do is I want to put parentheses around these guys and put them back together. So I want to put the parenthesis around the x minus 7, parenthesis around the x minus 2, and put them back together. X minus 7 times x minus 2. And of course the equal 0 is still out there on the right. So we're doing everything backwards. And now to get to the actual quadratic trinomial in standard form, you'd have to distribute and combine like terms. So if I went x times x, that is x squared. X times negative 2 is negative 2x. And then negative 7 times x, that's a negative 7x. And then negative 7 times negative 2 is positive 14. And of course, you still have this equals 0 out here. last but not least, let's combine the terms that are alike in the middle. So you have x squared minus 9x plus 14 equals 0. And ladies and gentlemen, we now have the quadratic equation that actually produces the answers 7 and 2. Right? So it's doing everything backwards as opposed to forward. Any questions on that? Again, this first part was not part of your homework for today. Today's assignment, what I would like you to practice with, is just questions 16 through 27. And of course, you don't have to do all of them, but this is just practice for you to get ready for the test. There is no quiz tomorrow. There's a test next Friday, right? So it's very, very, very important that we practice and get really good at this stuff. I will eventually give you some of these on the test next Friday as well, so you might as well start practicing some of these. I already did the solutions to this whole page. It's posted on Google Classroom, and for the rest of the period, we're just going to work.